Hello, good people of pre-calculus. This is Mr. Klein coming at you once again from the heart of the G-Wing. Today we are going to talk about quadratics, and we're going to be doing systems of equations with quadratics. You should be on lesson 2 in your Unit 5 note packet, and the first thing I need to do is make a couple changes here. We're going to call this vertex form, and then we're going to call this standard form. Okay, and with that in mind, without further ado, here we go. I want you to sketch the graph of the quadratic function that passes through these 3 points. And then I want you to write its equation in, I'm going to change it one more time, standard form. So when we're all done, we're going to have an equation that looks like this. Y is equal to a times x squared plus b times x plus c. And the challenge for us today, the game, is can you figure out what A is? Can you figure out what B is? Can you figure out what C is? Drawing the picture can be helpful sometimes. I can see that this parabola has to look something like this. I don't know exactly how low it goes or how high it goes, but I can see that it has to be facing upward. And because it's facing upward, we know right away that A, the leading coefficient, has to be a positive number. Now let's come on over here to the points. I noticed that this right here is the y-intercept, right? And so when we plug 0 in here and here, we have to get 1 out. So just because of this, you immediately know that C is going to be equal to 1, and we're a third of the way there. So step 1, I'm going to use the blue pen. I'm feeling blue today. Y is equal to, still don't know A, still don't know B, but we know C has to be 1. Now I'm going to make a little T here. And for my second step, I'm going to plug in one of these points. Let's go with the 4, negative 3. This says that if y is negative 3, then x is 4 squared so we plug the x value in here and here. And we get this expression, and let's clean it up a little bit. Negative 3 would be, what, 16 a's plus 4 b's plus 1. And I don't want that 1 over here. I'm going to move it over here. So I have negative 4 is equal to 16a plus 4b. And at this point, you should be thinking to yourself, oh, this is not enough information. I can't get the job done here. I have 2 variables, but only 1 equation. So that means I need another one. So continuing with step 2, you're going to do the exact same thing, but with the other point. So take 6, 7. Plug in the 7 here. And the 6 here. And the 6 here. So 7 is 36 a's plus 6 b's plus 1. So 6, I'm subtracting 1 here and here. 6 is 36a plus 6b. Now we got something we can work with, because listen, we have 2 equations. Here's the first one, here's the second one, and 2 variables. So we can set up a system. Now, hot tip, I noticed that I could simplify this one by dividing both sides by negative 4. Or actually, you know what? Maybe I'm just going to divide by 4. Let's keep that a positive 4. And that would give me negative 1 is equal to 4a plus b. And then over here, I'm going to play a very similar game. I'm going to divide both sides by 6. Do I have to do this? No, I don't, but I want to. And the reason I want to is look how easy these equations are going to be to work with. I'm going to grab this guy. I'm going to bring him over here. And now look how simple it's going to be for us to do an elimination. Okay, so we could call this the third step of the problem. Once you've got your two equations in the second step, in the third step you're going to put them together. Now I would like these b's to have opposite values, so I am going to take the bottom equation. Could have been the top, but I'll choose the bottom, and I'm going to multiply through by -1, which is going to change all the signs. That's going to leave us with 1 plus 1 is 2. 6a plus -4a is 2a, plus b plus -b is 0. Therefore, since 2 is equal to 2a's, that means a has to be 1, which tracks with right here, we said that a had to be a positive number. So now that we know a, we can go get b. You just pick one of the equations up here. I'm going to choose this one. And you plug the 1 back into it. So this would be -1 is equal to 4 times 1 plus b. Therefore, b is going to be -5. Final step, write your answer. Y is a quadratic equation where the leading term is 1, so it's 1x squared, plus the b value is 5 times x, plus the c value is 1. Or if you want to write it a little more neatly, we don't need that original 1, and we could just write our answer this way. Okay, pretty sophisticated problem. But then again, you're a pretty sophisticated student. Let's see if you can do this. Flip the paper over. I'm gonna hit the pause button. You should hit the pause button right now too. You're gonna work through this problem, and then you're gonna unpause it and check your answer. And here we are, we're back. Here's the answer. You should have gotten y is equal to -1.5 x squared plus 4x plus 7. One thing a little bit different about this one, when I plugged in the 2 points, let me get that out of the way. When I plugged in the 2 points right here, notice I already knew because the y-intercept was 0, 7, that 7 would be our c value. When I plugged in the 2 points, I ended up with a decimal value right here, which I didn't love. And then I took this right here, and I multiplied it by -3 so that I could get opposites. And then I solved from there. Okay, so there's our second problem. Let's move on to something slightly different, which is now we're going to be doing systems where you have more than one equation, and one of them is going to be quadratic. So in the case of this one, the first one is a quadratic. And I plugged a few points into this. When I plugged 0 in, I got 3. When I plugged 1 in, I got 0. When I plugged 2 in, I got -1. When I plugged in 3, I got 0 again. And when I plugged in 4, I got 3. So I know that this parabola looks something like that. The second equation here, x and y are both to the first power, which means we know that this is a linear equation. And I would probably take this one and rewrite it in slope-intercept form, which would give us y is equal to x take away 1, which means that our y-intercept is right here at -1, and the slope is +1, so up 1 over 1, up 1 over 1, up 1 over 1. Bum, 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 bum. Okay, so the parabola and the line, they intersect in 2 places. One of them is at 1, 0, and the other one is at 4, 3. So if we were going to solve this one by graphing, we would be done. Now I'm going to ask you to solve this one differently. I'm going to ask you to solve it by substitution. So let's bring our 2 equations down here. x minus y equals 1. Y is equal to x squared minus 4x plus 3. And there's a couple different ways you can attack this one, but I think to take this equation and rewrite it as y is equal to x minus 1, which we had actually already done right here when we were graphing the line, right? That's probably the move, because then you can just grab this, copy it, zip, zap, zoop it over here, and plug it in for that already isolated y, which would give you x minus 1 is equal to x squared minus 4x plus 3. And then this is going to be a factorable quadratic, so I want to move the x and the 1 to the side, which would give us 0 is equal to x squared minus 5x plus 4, which factors into x and x minus 1 minus 4. So x is 1 and x is 4. Keep in mind that this is going to give us points. So for the first one, x is 1. If x is 1, then y would be equal to, I'm using this equation, 1 minus 1, which leaves us with 0, which, hey, look, exactly the same as this point we got right there. And then for the second one, plug the 4 in. Y is equal to 4 minus 1, which gives us 3, and that tracks. So here are the solutions to our quadratic and linear system. One more problem on the backside. Let's do this one together. This one, you'll notice that the first equation has two squared terms, an x squared and a y squared. And that means that this is a circle. It's centered at the point 0, 0 because there's no like h or k here. And the radius is going to be the square root of 16, which is 4. So the circle will look something like this. 4 to the right, 4 up, 4 to the left, 4 down. Boom, 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 boom. Boom, 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 boom. There we go. So there's our circle. Our second one, only y is squared, and that's how we know that this is going to be a quadratic. So, hey, that's probably an important point to make sure you catch, that both squared, circular, only x squared, quadratic. So if we're going to plot some points in this, we could say, I know the y-intercept is going to be at 4, 0. Then it'll go over 1, down 1, over 1, down 1, over 2, down 2 squared, over 2, down 2 squared. And I'm saying down because this is a negative leading coefficient right here. So the graph is going to look something like this. So I can see that there are going to be 1, 2, 3 places where the circle and the quadratic intersect. And I can tell right now that this one is at 0, 4. These two right here, I'm not so sure about. It looks like the y value might be -3, but I'm not 100% on that. So on that note, let's solve the system algebraically by substitution. On this one of the things I want you to notice is that there's an x squared here and an x squared here. And if you see an x squared or a y squared on both sides, you can actually use that to substitute. So for example, on this problem, I would rewrite this as x squared is equal to 4 take away y. I added the x squared to this side, I subtracted the y to the other side. This means that anywhere I see an x squared, I can replace it with a 4 take away y. And I see one right here. So let's replace that with 4 minus y plus y squared is equal to 16. Move the 16 over. So we get y squared. Take away y. Let's see. Subtract 16 from 4, we get negative 12 is equal to 0. Factor time. Y and y. Minus 4 plus 3. So y is equal to 4, and y is equal to negative 3. Let's bring these answers back up here. The y equals 4 makes sense to me because we've got this point right here. And the y equals negative 3 also makes sense to me because we've got these 2 points right here, and the y value looks like it's about negative 3. So let's keep in mind that this one right here, y is 4. I'm going to plug this equation in. I'm going to plug that 4 in right here and use this to get our answer. So x squared is equal to 4 take away 4. And that would mean x squared is equal to 0. And that would mean that x is 0. Now in the second case, I'm going to take the negative 3 and I'm going to plug it in right here. X squared is equal to 4 take away negative 3. So x squared is equal to 7. Now if I solve that equation, I get 2 answers. I get x is equal to plus or minus square root of 7. And that's why if you look up here, see how there are 2 different points when y is equal to 3? They are negative roots of 7, which is size-wise, negative roots of 7 would be somewhere between negative 3 and negative 2, right? This would be negative roots of 9. This would be negative roots of 4. So negative roots of 7 is between roots of 9 and roots of 4. And our other point would be positive roots of 7, comma, negative 3. So in conclusion, we're going to get 3 answers. Here's the first one, here's the second, and here is the third. And that is the end of lesson 2. You can now go and attempt your problem set.